Okay, we'll get started. Welcome everyone to our webinar series. This is, I think, the 5th one as we're leading up to the summit. And today's presentation will be on the US AMOC science team. Gökhan Danabashoglu will be presenting. He is the chair of the science team. Gökhan, go ahead and get started.
Kristen, thank you everybody. Good morning or good afternoon, depending upon your time zone. So today, what I'll try to do is give you a brief summary of US AMOC science team activities and our future plans. As many of you know, it's a US science team, AMOC science team is a US interagency program funded through proposals by NASA, NOAA, NSF, and DOE. So what I wanted to do is first give you a brief background on science team objectives and our organization. Then I would like to show a few examples of ongoing projects, just a few highlights. Then briefly talk about our near and long-term priorities, and conclude with some thoughts and discussion items about the future of the science team. So US AMOC program scientific objectives include primarily 4 topics. They are listed here: implementation and evaluation of AMOC observing system, assessment of AMOC state variability and change, assessment of AMOC variability mechanisms and predictability, and assessment of the role of AMOC in global climate and ecosystems. As of the beginning of fiscal year 15, we have 48 funded projects supported by the 4 agencies that I mentioned earlier. So then the entire, essentially, science team comprises of PIs and co-PIs of those funded projects. And essentially, they are determined by the funding agency or program managers whether they are related to AMOC or not. And based on that, they become science team members. Then US AMOC program is organized in 4 task teams, and they reflect our objectives, as I said just on the previous slide. And our current membership for each task team is given here. And the membership, essentially, they rotate every year. So vice chair of this year will become the chair, and the chairs will be rotating off in October. And we'll look for new vice chairs for next year. Along with the task team leadership, the chairs and vice chairs, the science team chair, currently it's me, form the executive committee of the AMOC program. Executive committee is charged with identifying research needs to achieve the program objectives. We try to encourage and develop research activities to address these needs. We are also coordinating ongoing US and, whenever possible, international research activities to address the program objectives, summarizing the state of the science and program progress, and we also develop the inputs to AMOC program report as necessary. And I'll show you an example of this thing on the next few slides. Just to give you a brief history, and I put it on purpose here because it's going to be relevant for the sort of thoughts and discussion topics at the end. US AMOC, or AMOC itself, was identified as a near-term priority in January 2007, and the science team was formed in March of 2008. So we have been in existence for over roughly 7 years. And since 2008, we have been having annual meetings, and they are listed here. And starting in 2011, they have been joined with the UK RAPID program. And they are joined, we are doing that thing every other year, alternating years, and they are shown by the green meeting lines here. Indeed, our next meeting that's happening next week in Bristol is also a joint meeting between US AMOC and UK RAPID programs. I just want to also mention that we also had our external program review during 2012-2013 period, roughly. So this is the cover of our 2014 US AMOC Science Team Annual Report. It was published on a timely manner this time around, I think in March. And I would like to take this opportunity to thank all the PIs and co-PIs who contributed their progress reports in a timely manner. And also task team leaders spent quite a bit of time creating the synthesis of those submitted reports, and also coming up with after discussions with the task team members, with the near-term and long-term priorities of the US AMOC program. And I would like to thank in particular Mike and Kristen from US CLIVAR Program Office for their efforts in general for the US AMOC program, but in particular in preparation of this annual report. So now I would like to show you a few slides summarizing some of the ongoing work, and I can't touch on every single ongoing work, and I'm just focusing only a few of them. And starting with our cover page. Our cover page for the reports was from OSNAP, that stands for Overturning in the Subpolar North Atlantic. And I listed their scientific objectives here. It has two sections, essentially, OSNAP West and OSNAP East. One of our primary goals, both from the modeling side and the observations, to essentially determine connectivity of AMOC or meridional coherency. So these observational efforts, particularly this OSNAP one, is providing data for the northern North Atlantic. They are quantifying the subpolar AMOC and its intraseasonal to intraannual variability via overturning metrics, including associated fluxes of heat and fresh water. And another important objective here is the determining pathways of overflow waters in the North Atlantic subpolar gyre to investigate the connectivity of the deep water boundary current system. The entire OSNAP serving system was deployed in the summer of 2014, and I believe the first data returns from the moored instrumentation are expected in this summer, during this summer of 2015. However, the data from the full array will not be recovered until the summer of 2016. Another very valuable observational program continues to be the rapid MOCA array, which is at 26.5 degrees north. And we get updated transport estimates or transport values. What is shown here is the top left is the transport, volume transport. The bottom right is the corresponding heat transport. Individual components are shown here, but in the interest of time here, you can just focus on the red lines on the top left and black lines on the bottom one. Those are the total transports, volume and heat respectively. So an important essentially result, particularly becoming obvious as the time series get longer, is that we are seeing actually a decline of AMOC transport. And if you look at the first 5 years of the red line AMOC transport time series, initial first 5 years was about 18.7 square drops in transport, and over the last 5 years, that transport went down to 15.6. So that's a substantial, noticeable decline in the AMOC transport. And if you look at the heat transport, there's a corresponding decrease in the heat transport between the first 5 and the last 5 years. And those numbers above the black line show the annual mean transport, heat transport. And you can see that the heat transport declined by about 0.2 square drops during the last 5 years. And rapid will continue at least through 2020. Now, I wanted to also show you a contrasting picture here. This is from the MOVE array, Meridional Overturning Variability Experiment. That's at 16 degrees north. What this is essentially, this is not the complete transect. It's essentially measuring the southward transport on the western side of the Atlantic, mid-Atlantic ridge, and it's also below about 1,000 meters depth. And you can see that this actually array is indicating that in contrast with the rapid data, AMOC actually at this latitude, the southern branch of it is at least shown here, is increasing. So there is that discrepancy in the meridional coherency of observations at this point, and they are actually, the MOVE group is trying to figure out why this discrepancy is occurring. And finally, I mean, just to give you the idea about the meridional coherency, another observational program that I wanted to highlight was the SAMOC observational network that's being enhanced. The SAMBA array is being enhanced. So combined with essentially starting in the north with OSNAP, and there are some shorter array observational stations in between, RAPID, MOVE, and SAMOC is expected, they are all expected to provide us a more coherent picture of the AMOC from observations. And two modeling related slides. I just wanted to highlight a GFDL NCAR coordinated effort. This is led by GFDL, and we are doing correspondingly similar experiments both here at NCAR and at GFDL. The goal here is essentially looking at the climate impacts of the sea surface temperatures associated with the Atlantic multi-decadal variability. These are short integrations, but we have lots of ensemble members. The goal is essentially imposing a coupled system, observed SST in the North Atlantic, and determine their or simulate their climate impacts. What is shown on the left side, top left, is the AME plus anomaly is imposed in the North Atlantic. These are for sea surface temperatures. Of course, we recover the imposed anomaly. And if you look at the Pacific signal, we see a negative PDO phase. Then the question becomes essentially regarding that AMV signal in the North Atlantic, whether the North Atlantic SST signal or the tropical signal is impacting or creating these climate impacts. So subsequently, essentially, the right panels show where we impose only the North Atlantic SST anomalies, top panel, and the bottom shows where we impose the tropical Atlantic SST anomalies. And you can see that most of the climate signal is associated with what's going on in the tropical Atlantic, and in particular the tropical Atlantic SST signal. And how that signal, SST signal, comes about is still under investigation. And finally, I wanted to show you a reanalysis product comparison. This was actually discussed quite a bit in the Seattle meeting. These are showing the representation of AMOC in reanalysis product. The top panels show the time mean for the 1960-2010 period from 5 reanalysis products. The bottom panels show the AMOC trend during the same period, and the most bottom panel on the lower right is showing just a time series from a particular point, 1,000 meter depth at 41 degrees north. The point here is that, as you can see, the reanalysis products have quite substantial different representations of the AMOC mean state, and perhaps a little bit concerning is that the trends in the reanalysis products are quite different. You can see the AMOC, while ORAS4 showing declining AMOC trend, you can see that the GECKO product is showing an increasing AMOC trend. So just like in the forward models, the details of the reanalysis products matter quite a lot, and we should use both the reanalysis and the forward product with grains of salt and pepper, I guess, whatever you want to call them. Okay, so with that now, I would like to just briefly show you some near-term and long-term priorities. These were essentially updated over the last year. Each task team had many, two, I believe, conference calls with their membership. We also had extensive discussions at our Seattle meeting that occurred in September last year. So we came up with an updated list of near-term priorities. These are actually articulated in depth in the annual report, and I'm just showing you some highlights or bullet items here. For task team 1, near-term priorities include essentially improving understanding of the meridional coherence, as I mentioned earlier, of the AMOC and the mechanisms that control AMOC changes. And we think that the newly deployed OSNAP array and the augmented elements of SAMOC or SAMBA array will play key roles. Expansion of the existing observing system to better capture the deep ocean and to better quantify the role of deep temperature and salinity signals in contributing to AMOC variability continues to be a priority. We also would like to make these data sets available to the public as widely as possible, and also along with their error estimates. For task team 2, use of new and existing observations in combination with modeling experiments to refine our understanding of the present and historical AMOC is an important priority. Another emerging priority is to provide a more detailed characterization of AMOC flow pathways and their impacts on variability. Indeed, This particular near-term priority is highlighted in the recent call by NOAA related to AMOC. So it's essentially addressing this. Continuing development and investigation of AMOC fingerprints, investigating connections between surface forcing and historical AMOC variability, and developing a more comprehensive understanding of the strengths and weaknesses of existing global ocean reanalysis products and hindcats continue to be their near-term priorities. Indeed, I showed an example with the reanalysis product for the last bullet just a few minutes ago. Task Team 3 concerns the mechanisms and predictability, and lots of near-term priorities are listed here. They include investigation of how surface exchanges of buoyancy and momentum between the ocean and the atmosphere, cryosphere, drive the AMOC circulation across a broad range of timescales from monthly to millennial. It includes quantifying or clarifying the apparent disagreement between models of different complexity regarding the roles of Southern Ocean winds, for example, and the Nordic Sea overflows. And another item, for example, is essentially having a larger role for eddy-resolving models. I'm not going to go through all of this because you can read them in the annual report as well. Regarding Task Team 4, their near-term priorities include identifying the mechanisms by which AMOC variability imprinted on sea surface temperature and or cryosphere affects local and remote atmospheric patterns and phenomena. They're interested in assessing AMOC impacts on the cryosphere, particularly Arctic sea ice and Greenland ice sheets, assessing AMOC impacts on global and regional sea level, and of course, improving understanding of how AMOC variability affects ocean and atmosphere exchanges of carbon, biogeochemical cycles, and marine ecosystems. These are our near-term priorities, and for the first time this year, we also listed some long-term priorities. I just want to make sure that long-term priorities do not necessarily mean that they are not important at this stage. There are some, for example, either technical issues for their addressing them, or for example, if we have cheaper or less expensive observational programs, buoys and all that stuff, they can be essentially used in the future to increase our understanding of AMOC via observations. Similarly, from the modeling side, for example, we don't have enough computer power right now to run eddy-resolving models multi-millennium time scale to understand their behavior. So these are essentially targeting those aspects that are not necessarily addressable because of technological issues right now. And as I said, for example, the first item for Task Team 1 is find and or develop new technologies and methods for studying the AMOC and its key components to address the overall observing goals for AMOC in a world of finite resources. And if you look at Task Team 3, incorporation of mesoscale eddy-resolving ocean models more fully into the toolkits used for AMOC mechanisms and prediction work, including long-coupled GCM simulations, are included here. So with that now, I would like to just go to our sort of near-term plans. And this is our tentative science team meeting schedule. This is in light of the move to the new 18-month meeting cycle. As I said, this year's meeting is joint with the UK RAPID program, and it's happening next week. For next year, we are not going to have any US AMOC science team meeting. Instead, there's a workshop focusing on paleo and modern oceanographic data to understand AMOC over decades to centuries. So the goal here is that rather than having a science team meeting, open the workshop to somewhat broader AMOC communities so that interested PIs and co-PIs can participate in this meeting. And that is, I think, tentatively scheduled for late May, and it will happen in Boulder. And then we'll have two 2017 and 2018 meetings. 17 is just the US AMOC science team meeting. That'll hopefully occur in spring, early summer. And in 2018, that is expected to be a joint meeting with the UK program, RAPID program, and that's supposed to happen also somewhere in the US. Now, I would like to show you two slides related to our discussions, executive committee discussions, and I also gave an update to interagency group a few weeks ago regarding possible sunsetting of the US AMOC science team. That's why I was highlighting when the program started earlier in the talk. So the US AMOC program was initiated in early 2008. So and there's the expectation that the science teams are expected to end in a 5 to 10 year time frame. So we are approaching that timeline. And if you take that timeline as the guideline, then we have 2 to 3 years roughly as the lifetime of the US AMOC science team. And we had executive committee discussions related to this. And several questions came up, and I sort of gave these questions to the interagency group, and I would like to draw your attention to these questions as well here. And they include what should be an end product and how should it be developed? What is the target audience for this end product? What end products would be useful to US CLIVAR and the interagency group and their interests? What are the expectations of the US CLIVAR and interagency group regarding end products? How do we proceed? And do the executive committee terms stay the same to complete what's expected? So on this slide, I just wanted to make a case also. To me, personally, ending date of a science team seems a bit arbitrary. And we see benefits of extending the lifetime of the science team to, for example, match that of the UK RAPID program. And not only that, we would like to also make sure that the science team members take full advantage of the new observational data. For example, we haven't seen anything, OSNAP is going to provide observational data over the almost when the science team is supposed to sunset. And similarly, SAMOC, augmented SAMOC is the same way. And that science team provides an umbrella essentially for collaborations, information exchange. So anyway, we can discuss this issue if this is the format. But if we are expected to finish essentially the science team or sunset it, then a report perhaps needs to be written. These are just some ideas, discussion topics, highlighting the accomplishments of the science team over its lifetime and providing guidance for future AMOC-funded research. Accomplishments, for example, would be presented in the context of the original objectives and evolving priorities, and then we can we would document, then identify essentially remaining research needs and questions to be addressed beyond the lifetime of the science team. And that would include near-term, long-term priorities, which essentially highlight the gaps and unfinished business. That we can compile essentially a special issue for a journal. We can summarize all of our sort of accomplishments in a BAMS article perhaps, or we can produce a combination of the above. But given that we have task team rotation, leadership rotation occurring every year, I think based on the sort of requests of the interagency group and the US CLIVAR perhaps, it's better to form perhaps a writing team or a sunsetting team, that's what I was calling it myself this morning, that would build upon past leaders and new contributors to develop and coordinate planned documents and papers. Because in my view, with the current 1 year membership rotation, essentially it's going to be difficult to have continuation during the sunsetting process. And with that, I ran over quite a bit actually. I just wanted to finish with the flyer for our Bristol meeting and take any questions that you may have. Thank you.
Thank you, Gökhan. Very nice presentation. If anyone has questions, feel free to type them in the chat box or raise your hand. There's a little button at the top left-hand corner of your screen, and I will take you off mute. Okay, one more chance. Anyone have any questions for Gökhan before we end the webinar?
I should probably add that we will have an executive committee meeting next week at Bristol too, and I'm not sure which program managers are attending, but we'll have some discussions of the sunsetting and the expectations at that meeting as well.
Great. Okay, well, I'm going to go ahead and wrap up. I think most of you know how to reach Gokhan if you have any follow-up questions or ideas that you want to speak with him about. Thank you today for participating, and thank you, Gokhan, for presenting. Have a nice day, and this is the end of our webinar.
Thank you.
Bye-bye.
Bye.